On discovering that matter is made up of atoms, scientists' attention was shifted towards identifying the mass of atoms. Since atoms were small particles and could not be separated, scientists were not able to determine the actual mass of an atom by weighing it. It was possible to calculate the mass of an atom by weighing an element and then dividing the weight by the number of atoms. However, there was no method to count the number of atoms available in an element. In an attempt to find a solution to the problem in the 19th century, Dalton made some assumptions based on Gay-Lussac's findings. Based on Gay-Lussac's findings, Dalton assigned hydrogen a weight of 1. He used hydrogen as a standard for determining the atomic masses of other elements, and published the first table of atomic masses. Note that the atomic masses in the table indicate relative mass and not the actual mass of the atoms, which means that the masses of elements is relative to the mass of hydrogen. In 1961, scientists met at the International Union of Pure and Applied Chemistry and decided to use carbon as the standard base. Carbon has 3 isotopes, C12, C13, and C14. Since C12 was found to be the most abundant, it was taken as the standard scale. By that time, due to the advancement of technology, scientists started using a mass spectrometer to calculate the accurate atomic mass of elements. The atomic mass of carbon was determined using a spectrometer and was found to be 12 atomic mass unit AMU. All other atoms were assigned a mass relative to the atomic mass unit of carbon. Thus, the atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon taken as 12. As carbon-12 is an isotope of carbon, it is represented as 12C. Therefore, one atomic mass unit is defined as a mass equal to 1/12 the mass of carbon-12 isotope. And the value of one atomic mass unit was determined to be 1.66056 multiplied by 10 raised to minus 24 gram. Let's determine the atomic mass unit of hydrogen based on this formula. We know that one atomic mass unit is equal to 1.66056 multiplied by 10 raised to minus 24 gram. The mass of a hydrogen atom was determined using a spectrometer and was found to be 1.6736 multiplied by 10 raised to minus 24 gram. Therefore, in terms of atomic mass unit, the mass of an atom of hydrogen atom is said to be 1.008 AMU. When chemists expressed atomic mass on carbon-12 scale, they named it as unified scale, and the unit was represented as U instead of AMU. Though AMU is still used in most places, chemists now use U as the unit. Hence, we can represent atomic mass of hydrogen as 1.008 or 1U, and that of oxygen as 15.9994 or 16U. We know that when atoms of the same elements possess different atomic masses, they are known as isotopes. Hence, for isotopes, the average value of the atomic masses is considered as the atomic mass unit. For example, chlorine has 2 isotopes with average atomic masses of 34.97 and 36.97 units respectively. The relative abundance of the isotopes is 0.755 and 0.245 respectively. Relative abundance refers to the abundance isotopes of an element, as naturally found on a planet. Average atomic mass of an isotope is the sum of abundance of each isotope multiplied by the precise atomic mass. Thus, the average atomic mass of chlorine is calculated as 35.46 U. Hence, the average atomic mass was redefined as the atomic mass of an element is the average relative mass of its atoms as compared with an atom of carbon-12 taken as 12 U. We can also calculate the average atomic mass using fractional abundances of isotopes of an element. Fractional abundance of an isotope is the fraction of total number of atoms that is comprised of that particular isotope. The formula for calculating an average atomic mass from fractional abundance is fractional abundance multiplied by atomic mass of that fraction. Thus, the average atomic mass will be the sum of the products of fractional abundance of the isotopes and their corresponding mass numbers. For example, neon consists of 3 isotopes: neon 20, neon 21, and neon 22, which have mass numbers and fractional abundances as shown in the table. The average atomic mass of neon will be calculated 20.179 U. When the atomic mass of an element is expressed in grams, it is called gram atomic mass. Gram atomic mass is also called 1 gram atom of the element. For example, 1 gram of magnesium is equal to its atomic mass expressed in gram, which is 24 gram. Like atoms, molecules are also very small. Hence, their mass cannot be determined by weighing them. Therefore, the molecular mass is determined relative to the mass of carbon atom taken as 12 U. The molecular mass of substance, element, or compound is the number of times the molecule of the substance is heavier than 1/12 the mass of an atom of carbon-12. In other words, we can say that the molecular mass of a substance is the average relative mass of its molecules as compared with the mass of an atom of carbon-12 isotope taken as 12 U. The molecular mass of any element or compound can be calculated by adding the atomic mass of all the atoms present in one molecule of that element or compound. For example, the molecular mass of water will be the atomic mass of 2 atoms of hydrogen plus the atomic mass of 1 atom of oxygen, which is 18.02 U. When the molecular mass is expressed in grams, it is known as gram molecular mass. Gram molecular mass is also called 1 gram molecule of the substance. For example, 1 gram molecule of water is 18 grams. Lastly, let us look at ionic compounds. Ionic compounds such as sodium chloride or potassium nitrate do not contain discrete molecules as their constituent unit. The ions in such compounds are closely packed in a 3-dimensional structure. For example, in the sodium chloride crystal, an ionic bond is formed between a sodium ion and a chloride ion. However, in its crystalline form, each sodium ion is surrounded by 6 chloride ions. So, we have to calculate the formula mass instead of the molecular mass. Formula mass is the sum of atomic masses of atoms present in one formula unit. Thus, the formula mass of sodium chloride is the atomic mass of sodium plus the atomic mass of chlorine, which is 58.5 U. When the formula mass is expressed in grams, it is known as gram formula mass.